Now that we've seen one demonstration with the 60-degree Catalase solution, I'm going to show you an entire run of our room temperature solution. I make sure that my timer is ready to go. Have that set up first thing. Reset, right? I'll put that over here so that we can see the time running. What's really important is once you start your measurements, your recordings, one person in your group needs to keep an eye on that timer, because as you're about to see, this solution will gain foam quite quickly. That moment it's 1 minute, we need to read exactly off the measuring cylinder using our graduated cylinder linings, measure exactly where the foam height has reached, because it will continue to rise and therefore your results are not accurate. So I'm going to demonstrate the entire run from start. We need more hydrogen peroxide, so I grab 3 mils, measure it out very carefully. Again, squeeze, lower, release. There's another few mils. Carefully add it to my smaller measuring cylinder, and I need one more, so squeeze, lower, release. Being very, very careful to make sure I don't have too much. If I have too much hydrogen peroxide, I'm introducing a higher concentration and higher volume of substrate. Therefore, there's more for my catalase enzyme to react with. I'm going to get a greater reaction. Keep in mind, this whole experiment is testing how does temperature impact the rate of reaction of an enzyme. So if we're adding more substrate to the reaction, you're obviously going to get a larger reaction, which is completely irrespective of the temperature. I have my room temperature catalase solution ready to go. I pour that into my measuring cylinder. We don't want that to stay out too long if it was a different temperature, because it's going to get warmer or colder depending on what it was starting at. My timer is ready to go. The moment I pour my solution of hydrogen peroxide into the beaker, and you'll see it react very quickly, I need to press start. Pour it in, start the timer. Now we're going to let this go for 1 minute. And again, what's really, really important, as you can see, the foam is increasing and increasing and increasing. It's quite fast. Once it hits 1 minute, I need to read exactly off those lines as to how many milliliters was produced of foam. So in the rare occasion that my foam height exceeds 100, at the end of the experiment, once that 1 minute is up, you can use your ruler to take a different measurement. Now that's not ideal, so we might repeat the measurement. However, those kinds of errors and points of discussion are really important to be writing about in your full discussion section of the practical. 40 seconds have passed. This foam height is increasing very fast. As you can tell already, very, very different to our 60-degree result. 10 seconds to go. This is now where one person in your group needs to be really careful to make sure they are observing exactly where, so get down low, exactly where on the cylinder my foam height reaches. There's 1 minute. So we stop and we read off where that occurs. Write that one down. That's really important. We repeat this 3 times. 3 times gives us a nice range, and it allows us to assess whether or not there's a random spread or maybe some random errors occurring. One thing to be aware of, as you'll be able to see, this foam did not rise horizontally and flat. We have a peak on this side of the cylinder. That's something you or your group need to discuss as to where the measurement is taken from. As long as you are consistent across all your trials for all temperatures, it doesn't entirely matter where that height is recorded, but we do need to be aware of the fact that there's not a consistent flat line rising up the measuring cylinder. So here is are our results for the room temperature. Here are our results for the 60 degrees catalase solution. Clearly you can see a very, very distinct difference between those foams. It is entirely up to you in your justification of the results to explain why this difference is occurring. This is room temperature. This is 60 degrees. Have a think about what temperature's impact is on catalase as an enzyme, as an active site, as a shape, and its ability to complete its function. That would allow you to discuss maybe why there is more foam, which is occurring from the breakdown of hydrogen peroxide, than in the 60 degrees.